Okay, hello, welcome to the part 2 of the week 4. So, in the previous lecture, in the previous part, I covered the basics of this text. So, there was nothing special. It was quite easy to implement the stack with simple linked list, right? So, this stack can actually has a linked list as a property of this tag. Of course, there is another way to implement it. It is kind of this, right? As a subclass of the linked list, we can implement this tag. That's one way. That's another way around to implement this stack operation. Okay. So, but we looked into this case. In this lecture, in this part, I'm going to cover the queues. So, one of the key characteristic of this tag was what? Rest in, right, and first out. Means that the last one comes in will get out first, right? We call it rifle. And what we are going to cover in this lecture is that is Q, and Q has first in, first out, called FIFO characteristic. So it's kind of opposite concept of a kind of concept opposite to this tag. So let's start. So this is a scenario for the queue operation. Imagine that we have this line in this airport. By looking at this line, you can see that kind of most one facing this direction, right? Means that people are going this way, and there must be some kind of gate, and there is a line entrance here, right? So people come in, and people will get out here, right? So so there is a way for going in means here, and going out means here, right? So at the end of line, one gets in, and at the first of the line will get out. No one gets in the middle of the line, right? Usually what you have is that we have this kind of guiding pole line, and usually people don't get out or get in the middle, right? So that's one scenario of the airport, and equivalently there is another scenario of the production line at the factory. So in this case, imagine that this is called what? Is called conveyor belt, right? And this conveyor belt might go one direction, and then we put a box here, and there is some kind of process going on, right? And this box will get out for the further production operation, right? So in that case, this is called like the first thing. This one was coming first. This one was the first one to come in. This one was the last one to come in. Who will get out first? Of course, this one will get out first, right? So it's called FIFO, right? So this is a perfect scenario for the queues, right? So queues actually are linear like linked list, a variation of a single linked list. Difference is that it's voluntarily giving up the access to the middle in the linked list, because there is a pole line like this, so that people don't get in the middle. This is prevented, right? And people only get in at the entrance, and people only get out at the exit, right? So that's the queue. It's voluntarily giving up the middle access, and only access to the first and the last instances in the list, right? So the only first and the last, right? So first instance in the list is the front instance in the queue, and the last instance in the list is called the rear instance in the queue. So rear, right? It's called like the back at the end, right? This kind of meaning, and front is the like the face and the front, right? So an item is inserted at the rest, it means that at the rear, and an item is always removed at the front is called front, right? So right, so the mechanism is called FIFO, as I said. So imagine that we have this singly linked list, and we simplified it so that we just ignored head and tail, this diagram. Of course, we might have one in the actual implementation. This one get out, this one will get out, and this one will get out the rest, and this one was just inserted in add, right? So that's how the queue operates.